Welcome to Tech Talk with Rishi.
That's
So
you.
can you introduce yourself also?
Sure. I'm Jared Porcenaluk. I'm a software developer at a company called Nebbia Technology. And I wear a few more hats than just software developer there because there's a lot involved with working at a company that does primarily consulting in the DevOps and Azure space. So I just like to think that I help people with DevOps and Azure excellence and help them avoid common pitfalls and really make the most of their development time. I also help organize the Orlando IoT meetup, and I've been interested in IoT for about 5 or 6 years now, and am working to apply that IoT and DevOps knowledge with clients at Nebbia.
That's great. You have some experience in the field. So I was going to ask you a couple of questions today regarding IoT, Internet of Things. What is machine to machine application? What are some machine to machine applications in the world?
Yeah, great. So I think I can answer both questions because machine to machine applications have existed for a long time. Like machine to machine is just saying, you have a physical device that interacts with the real world. And once it's done with its thing, for example, maybe it needs to tell another machine that it's done and that machine needs to do something. This happens all the time in factories, for example. And it's been happening since the turn of the century. It's just that communication started as analog and then it moved to electrical, and now and even decades before now it became digital. And so now what we're seeing is that digital communication not only happening inside of factories and like a closed network, but happening across the world, across open networks like the internet. So the first internet connected machine was actually a Coke machine at MIT, and it reported its status on the network, like how cold was it, et cetera, and it could be read globally. And that was in the 1980s. But today, because of the cost of hardware going down, and because connectivity going up, and because the power of computing becoming smaller and smaller and cheaper, basically, we're starting to see like a plethora of these machine to machine applications happening. And there's been a new term slapped on it, Internet of Things, but essentially it's solving the same problem. How do we get something to talk to something else? And I think the reason why it changed from machine to machine to Internet of Things, the term, like the common vernacular of how people talk about it, is because instead of just talking from one machine that's sitting beside another machine, it's more of an appliance or machine talking across the world to another machine. And so, some real world examples. I mean, uh, I like to say that anytime a human has to go look at something, that's a ripe situation for the Internet of Things, because when you have a person going to look at something to check a box and say, yeah, it's on or it's off, that's a time when a machine could probably do it faster and more efficiently. And this is happening in many different industries. So, transportation, retail, energy, factory automation. These are places where internet connected devices talking to each other make a lot of sense. And it's also happening, of course, in the consumer level. I have a Nest thermostat, and it's been a life changer. I was able to tell when my AC system broke from my office downtown where I work. And I was able to come home and call somebody out here to fix it. And then you could imagine the next step would be when my AC breaks, somebody can just come automatically to fix it. And then you can imagine maybe instead of the AC breaking, it recognizes that it's about to fail, and so it decreases power or otherwise tries to do some things to save itself from failing. And so there's just so many things that are happening, and then I think are going to continue to mature and become even more helpful for us as we go down that road.
I agree with you, and I also like the point that you shared, especially that in the 1980s there was an IoT machine, so it has been a long time since IoT has been here. Now,
Yeah, definitely.
another question I wanted to ask you was, what are the main parts of an IoT system?
Yeah. So there's there's two things at the edge that make something an IoT system. Like, and it's the start of the system. It's either an actuator or a sensor or both or many of them. But a sensor basically is how a device reads the world. So the real world is very analog, it's physical. How does that become digital? Well, that's through a sensor. So a temperature sensor or humidity sensor. And there's sensors for all sorts of things, pressure and you know, water level or anything like that. So sensors are the way a device can sense the world, read the world, like our eyes or ears or fingers. And so that's like a piece of an IoT system that definitely needs to be there, either a sensor or an actuator. An actuator is how a device interacts with the world. So it could be a motor or a stator, something like that. So if a device has one of those two things, then that's kind of like a bare minimum for saying we have an IoT device. The next step for it to be an IoT device is some sort of computing piece, a module, a device that takes that sensor data and sends it to the internet, and or takes information from the internet and uses that to decide when to actuate an actuator. So when you have a sensor or an actuator or both, a device, and then a communication off of an across a network, that's technically an IoT system. It gets much more complicated as the real world intervenes. You know, you could have hundreds or thousands of sensors, hundreds of thousands of devices. They could be talking to your cloud backend, which then interacts with other APIs, for example, or other physical devices that are in that location. So it can get really complicated really quickly, but the basic system, basic IoT system is either a sensor, an actuator, or both, a device that takes that analog signal from the real world and turns it into a digital signal for a network, or takes a digital signal from a network and turns it into something physical in the real world.
That's a very good explanation of an IoT system. Now, another question that we were going to discuss, so this applies to all the people who are in IoT. What are some major challenges when implementing an IoT system, and what are some ways to overcome those challenges?
Sure. Yeah. Oh, man. So IoT is very different from software. Like, I'm a software developer, so I'm looking at it through that lens myself. And for me, like, if I wanted to make an application for like a website, I have everything in my power to do that. I can write the code, deploy the cloud, update it. I know how to do all those things really well. When it comes to IoT, there's many different moving parts. So there's the hardware and the software and the firmware and the connectivity, the cloud backend, and all of them need to work together. And each piece of that puzzle requires deep expertise. Like, hardware is not something that you can just dabble in if you're going to be making something that's going to run in production. It needs to really be made well. Physical security is a thing. You know, you have to have fault tolerance, that sort of thing. So you don't want to just play around with the hardware side if you're intending for this thing to live for a long time and be secure and all those things that make something robust. So one of the major challenges of IoT is getting all the people from all these different disciplines and roles to work together to create a production ready IoT device. Even if it's inside of an enterprise, it still should be production ready, even if you're never going to see it on a store shelf. Um, I was at a Microsoft IoT event here in Orlando, and they mentioned that a typical IoT project touches like 6 or 7 of their partners before being in production. And it kind of speaks to how complex this area can be. But one of the cool things is that as this area becomes more mature and it starts to get democratized a little bit. So the Internet of Things tools and methodologies are becoming easier to work with. For example, it used to be that you'd have to create your own protocol to talk from one machine to another machine, or use an industrial protocol that's very difficult to understand. But then Microsoft has come out with tools like IoT Hub. And IoT Hub uses a pretty standardized protocol out of the box, uh, MQTT. It also can use HTTP or AMQP or whatever that other one is that's a little more obscure. But basically, there's standard ways of communicating across a network inside of IoT Hub, and then they wrap like those standard ways of communicating with secure certificate-based authentication and more robust fault tolerances for communication, so that if you send a message, you'll be reasonably sure that it will arrive where it needs to arrive. So all those things that you'd have to worry about, they've abstracted. And so that's happening not just in the communication between the device and the cloud, but it's also happening at the hardware level. People are making it easier and easier to use out of the box hardware. There's more and more options. And so as more and more people get into the space, things become easier and easier to work with. So now is a really great time to get into the space. But there's definitely still a lot of technical hurdles to go. The biggest one, I think, is security, because even though there are great abstractions I'm a Microsoft guy, so I'm going to use Microsoft as an example. So even though Microsoft Azure has great abstractions over the hard problems of security, and they've introduced things like Azure Sphere, which is, device at the edge, the hardware and the operating system that runs at the edge. They give you that, platform, and they give you the communication to the cloud, and they give you the cloud backend, and they say, okay, here's this. You can't mess this up. We built this. Don't touch these underlying layers. You just have to write the code that runs up on top of it. We'll take care of the underlying security. Even though there's things like that out there, that doesn't solve every problem in IoT. And so just basically, security is one of those things that continues to be an issue for IoT. And because we're attaching physical things to the network, the ramifications of it going wrong can be really big. Like if you have an oven and it's connected to the internet, and someone hacks into your oven and turns it all the way up in the middle of the night, that's a problem. So we really, really need to get security down pat if we want to see IoT succeed. And that's a huge challenge because it's ongoing. There is no point where you can say, okay, we're done with security. And it's always imperfect. There is no perfectly secure system. There's always a way to breach it, whether it's through social mechanisms or technical mechanisms. So definitely, if you focus on IoT and security, there's a lot of value to bring there. And then one of the other areas is more social, and that's privacy. So when we connect all of our things, we've seen some of the issues from privacy arise when we have a phone in our pocket, but that's just one device. When we start connecting all of our devices, it becomes easier and easier to pinpoint where people are, what they're doing, why they're doing it. All of these different data points can be used against someone. And we're not really sure the ramifications of all this data collection that's occurring right now. So we've seen some backlash from that, even without IoT devices, even when we're just talking about Facebook and Twitter and things like that. So When we throw physical things into the mix that can track our whereabouts and what we're doing and how and why, then we definitely need to have a social conversation about that, and that's a big gray area. And then finally, I think one of the things that people gloss over in IoT is the DevOps of IoT. So it's definitely an area that I'm highly interested in because I work at Nebbia and we're a DevOps company. And DevOps is about the tools, processes, and people of delivering value. And when DevOps is done really well, companies do really well because that feedback loop between an idea or a bug fix and delivering value becomes shorter and more reliable, and companies are able to move and react faster. And when it comes to IoT, it's very different than from web applications or even mobile apps because the ramifications are so high, again, for if it goes wrong. Like just the other day I saw a news article about Nike has these self-lacing shoes, and apparently they sent an update to these self-lacing shoes, which are really cool. You put your foot in and press a button and it laces themselves. But apparently an update they sent bricked them, so they no longer worked, which is funny when it's shoes, but it's when it's your car or your oven or your air conditioner, you know, that becomes a big problem. So if IoT is going to be continue to be a thing and it continue to work its way into all of our devices, then we really need to make sure the benefits outweigh the risk. And to make that happen, we need to lower the risk. So we need to get more disciplined about the process of delivering updates and delivering bug fixes to these Internet of Things devices and testing them along the way. And that's exactly what I'm looking to do with my work at Nebbia, basically, because I see that as a huge challenge we need to overcome.
That's a good explanation. You covered all the points surrounding IoT, I think. Now, you were mentioning that it is now getting easier to get started with IoT. You also mentioned some tools like MQTT, which I believe is a open source framework, or it is something to transmit data over IoT devices. I had a question.
Yep.
I mean, how can one get started with IoT?
Yeah, that's a great question. So, um, one of the easiest ways to get started, I think, is just open up your favorite search engine. I use Google and just type in IoT starter kit and attach, like, let's say you're a software developer, attach your favorite language at the end, maybe, or your favorite cloud. So IoT starter kit, Azure in my case, or Azure IoT starter kit. If you're more into AWS, it'd be like AWS IoT starter kit. And there's plenty of resources out there they bundle together hardware and they bundle together instructions and Git repos and everything. They send them to you in a nice little package, and it's really a nice, convenient, easy way to get started. And from there, you can grow in any direction. If you're more interested in the hardware side, delve into the hardware side. If you're more interested in the software side, delve into the software side. But that's a really easy way to get started. One of the one of the ones that I recommend is the Azure IoT Dev Kit. Dev Kit being all one word, DEVKIT. And the Azure IoT Dev Kit comes with a little piece of hardware, and that piece of hardware has sensors built into it. And so you don't need to worry about voltage, you don't need to worry about amperage or anything like that, what type of sensors to buy, how they'll integrate with your hardware. And that's very different from like using Arduino or Raspberry Pi, where you do have to worry about that sort of thing. And what's really cool about the Azure IoT Dev Kit is that the device that it comes with has Wi-Fi, so it does connect to the internet. So you can start connecting it to the internet. And it comes with code samples from GitHub and a plugin for Visual Studio Code that works really nicely with it. So it's kind of a comprehensive solutions that you can get started with some tutorials in like an hour or two, and then you can expand upon that however you'd like. So definitely Azure IoT Dev Kit would be a great option. If you're not a software developer, if you're more into the hardware, I think I have less advice to be able to lend you, because I think getting started requires a little bit of knowledge of code. But even if you don't have a strong foundation of code, if you understand a little bit, you can still get a dev kit, plug it in, run a sample, and start, playing with it a little bit, playing with the variables. So it definitely is the place I would start.
That's great. There are a lot of tools for IoT now. I have a Raspberry Pi free installing Windows on it. I can install Windows on it as well. So it has some features that can work cross platform.
Yeah,
There's also Arduino, and as you mentioned, there's a Azure Dev Kit, something that I will be looking into. Another question we were going to look into was what skill does one need to create or implement an IoT system?
yeah, that's a challenging one. I think so. It's easy for me as a software developer to create something and stick it in the corner of my house and have it, read the temperature and send an update to my email or Twitter or something. So creating an IoT system is pretty attainable for anybody with basic coding skills. And it doesn't matter what language you use. Like even though I use C sharp and JavaScript day to day, like a basic system that even uses C or C++, it's pretty understandable to read a sample code base and make some changes. But when you want to go beyond that, when you want to go beyond creating stuff for yourself, and you want to start really tackling the things that make an IoT project ready for other people to use, that's when it gets a little more complicated. That's when it takes more than one person's set of skills to create things that are robust enough to be production ready. So that's when, if you know a lot about hardware and you don't know a lot about software, you can contribute a lot to an IoT project as part of a team. If you know a lot about connectivity, or you know a lot about installation of hardware, like you can contribute to a team. So I think it depends on what your goals are with IoT. Like if your goal is to automate something in your house and have fun with it, like some basic coding skills are extremely helpful. A little bit of knowledge about voltage and amperage and what type of sensors there are is helpful, but that can be gained over time. But if your goal is to like implement a full IoT system at your job, or for your clients, that's where I would say like assembling the team is the biggest skill that you'd need. Finding the right people to work together to create something that's going to not fail the day you turn it on. So it's definitely a broad range of skill sets depending on what your goals are for building an IoT system.
We covered all the questions and you gave a really good explanation. I had a last question for you. Is there any links you want to share or anywhere people can find you?
Sure. So my website is jaredporcenaluk.com. So it's JaredPorcenaluk.com. And on there, I'm working on a project that kind of shows each part of how I'm building an IoT system that can be built, that really takes into account DevOps and takes into account the enterprise considerations that one would have about security and updating and reliability. But I'm taking all those concepts about enterprise grade IoT systems and applying them to something that's well, it's not serious. I'm connecting my 1988 Ford Bronco 2 to the internet. So If you follow my blog, I have updates about what hardware I chose, what software I'm choosing, what operating system, the process of trying to find sensors that will work. So it's really kind of like a behind the scenes look of building an IoT project. And I'm going to keep providing updates over the next 6 months or so about how all that's coming together.
Great. Thank you for all your answers, Jared. You provided some great insights on the IoT platforms as well as the various ways to get started with IoT. You're welcome to be on the podcast again in the future. You can just contact me. And it was a great time talking to you.
Yeah, thank you so much for letting me come on. I really appreciate it.